Picture an exhibition hall in Shanghai, packed wall to wall with humanoid robots, walking through crowds, shaking hands with visitors, even directing traffic outside the building. This wasn't a concept demo. It happened just this month, and it's forcing a serious question. Has China quietly taken the lead in the race to build intelligent machines? In mid-July 2026, China held its World AI Conference in Shanghai, and the numbers alone made headlines. More than 1,100 companies participated, and according to state media, Chinese firms have now developed over 400 distinct humanoid robot products, more than half of every humanoid robot model that exists on Earth. Before we go further, if you're into stories like this, where technology and global power collide, consider subscribing. Now let's get into what actually happened, and what it means for the US. At the conference, humanoid robots weren't just standing on stages. They walked the exhibition floor in traditional Chinese opera costumes, worked alongside industrial displays, and demonstrated tasks tied to manufacturing and logistics. Huawei showed off its Atlas 950 SuperPod, a massive AI computing system, while companies like Unitree and Fourier displayed robots aimed at everything from factory work to home companionship. This is confirmed, reported activity, not speculation. China's Ministry of Industry and Information Technology has publicly stated its ambition to push humanoid robots from lab prototypes into mass commercial production, backed by dedicated state investment funds worth tens of billions of yuan. Why does this matter beyond the spectacle? China faces a demographic problem most Americans underestimate: a shrinking working-age population and a manufacturing sector that increasingly can't find enough human labor to fill factory floors. Humanoid robots are being positioned as a direct answer to that shortage. At the same time, global manufacturers are watching supply chains shift, and whoever controls robot hardware production at scale could end up controlling a critical piece of future industry. There are also broader strategic implications tied to automation and national competitiveness, though it's worth being careful here. Public reporting focuses on industrial and commercial ambitions, not confirmed military applications. So, how does the United States actually compare? This is where the picture gets more balanced than headlines suggest. America's strength isn't in the sheer number of robot models. It's in the intelligence running them. OpenAI and NVIDIA continue to lead in foundational AI models and simulation platforms like NVIDIA's Isaac GR00T, which multiple robotics companies, including firms outside the US, rely on to train their machines. Tesla's Optimus program is now converting real factory floor space at its Fremont plant for robot production, following confirmation from Elon Musk during Tesla's Q2 2026 earnings call. Figure AI has documented verified deployment inside BMW's Spartanburg plant, logging over 1,000 working hours. Boston Dynamics Atlas recently gained Google DeepMind's Gemini AI models, combining elite hardware with frontier-level reasoning. Agility Robotics and Aptronic both have confirmed commercial pilots with Amazon and Mercedes-Benz. American venture capital funding into robotics also remains enormous, and U.S. semiconductor technology, especially from NVIDIA, underpins much of the AI training happening globally, including in China. China's advantage lies elsewhere: manufacturing scale. Chinese companies can produce hardware components, actuators, and complete robot bodies faster and at lower cost than almost anywhere else, thanks to a mature electronics and EV supply chain already built for mass production. That's precisely why China can showcase over 400 robot models, while U.S. companies focus on fewer, more specialized platforms. So who's really winning? Right now, it depends entirely on which category you're measuring. On raw AI capability and software sophistication, the U.S. still holds a real edge. On hardware manufacturing volume and speed to market, China currently leads. On verified real-world commercial deployment, meaning robots doing actual paid work today, the picture is closer than most people assume, with the U.S. holding several confirmed industrial pilots. Neither country has definitively won this race. Looking ahead, both nations are chasing similar goals: robots in factories, warehouses, hospitals, and eventually homes. These possibilities are realistic, not guaranteed. Real obstacles remain, Cost is still high, safety standards are still being written. Reliability over months of continuous use is still unproven, and public acceptance of robots working closely with humans is still an open question. Analysts broadly agree these challenges will take years, not months, to solve. So where does that leave us? China has demonstrated staggering manufacturing scale and government-backed ambition. The United States maintains a strong lead in the AI models and software that give these robots their intelligence. Both nations have real, verified progress, and both face real, unresolved challenges. The race isn't just about building better robots. It's about shaping the future of work, manufacturing, and artificial intelligence. Which country do you believe will lead the humanoid robot revolution over the next decade? China or the United States? Tell us why in the comments. And if this kind of analysis is valuable to you, hit like, subscribe, and turn on notifications so you don't miss what comes next.